All right, I'm going to begin on number one. If you'd like to work kind of on your own, if you're feeling confident, go ahead. Yeah, maybe. Yes. You need to be here, you need to participate. This is good review because the review that we're doing is kind of college level type questions. So, well, you saw the CWU exam last semester. You know what you're looking at. All right, so first thing I want to do is sketch this thing. I'm going to draw the ground and a vertical line. And then the tree itself is leaning, inclined at an angle of 10 degrees from the vertical. So it's a little exaggerated, but let's say this is my tree here. That would be 10 degrees from the vertical. And there's some point 60 feet from the base of the tree. So the base of my tree is here, 60 feet away. With the tree leaning towards the observer. So the observer is here 60 feet away, and they're going to measure the angle of the elevation to the top of the tree. Is 24 degrees. So angle of elevation is always measured from the horizontal. They want to know how high above the ground is the top of the tree. So they're asking us to find basically this distance here. All right. So if we're trying to find triangles, the triangle that jumps out at me right now is this one here. I'm going to sketch it separately and see what we can label from that triangle. I know that this side is 60 feet. I know that this angle here is 24 degrees. There's another angle that we should be able to find here. This one right here, we should be able to write this angle down. It should be 80. Agreed?
Oh, yeah.
We got 90 here, so this would have to be 90 altogether. That consists of a 10-degree angle and an 80-degree angle. So if that's 80, then we should actually be able to figure out the third side of the triangle also. 76 up here. 76 plus 24 plus 80 should equal 180. So this is 76. Any questions thus far? So I think we could find any other missing sides of the triangle if we want to, and then maybe split it into a couple of right triangles and use SOHCAHTOA to find the H that we're looking for. So my strategy is going to be, I'm going to find one of these remaining sides. I think I'm going to go for this one here. I don't know why in particular. I could have gone for the other one. And then once I've got that, then I can look at this right triangle that's got the 24-degree angle. This would now be my H. And this would be that same piece. So basically, I'm going to split off this triangle here. That's what this little triangle is. So we got a lot of pieces. We got a lot of parts and pieces to do. Unless someone's got an easier way to do this. Anybody have any suggestions other than that? What do you mean? 76 and 80? This one here?
Yeah, like on the diagram.
On the original diagram, it would be this triangle right here. Would you agree that this would still be H, right? And So if I knew this, then I would have enough to solve. I mean, it'd be awesome if I knew like that this and this were like 30 and 30, like half of 60 and half of 60, but we don't know for sure how it's cut up. In fact, I know for sure it's not going to be half and half, because if it was half and half, these two angles would be the same. So that's my overall strategy. I could have gone with this triangle. There's another right triangle over here. I could have solved for this side instead, but it doesn't really matter. So let's see if we can find this side right here. Does this look like a law of sines problem or a law of cosines problem? I'm talking about finding this side right here. I cannot use SOHCAHTOA for this because it's not a right triangle. So I'm stuck with law of sines or law of cosines. Which one's going to be our best bet here? Some of us are really going to need to spend some time reviewing law of sines and law of cosines. To me, this looks like law of sines because I have a side across from an angle here, and I've got an angle across from the thing that I'm looking for. I'm going to go ahead and call X for right now. That really looks like a law of sines problem to me. So let's solve for X here using law of sines. Let's see. So sine of 80 and X should go into one of my fractions. Sine of 76 and 60 should go on my other one. And then I just need to cross multiply and solve for X. All those angles are in degrees, so I better be in degree mode on my calculator, and I am. Ooh, let's try that again. That's better. About 60.90. If I round to 2 decimal places. Seems reasonable. So that's what this is right here. Any questions so far? Do we remember setting up law of sines, law of cosines before? That's something you will see on your exam. A big part of chapter 5. Most of you did really well on that portion of the test, so it's probably going to be a matter of going back and reviewing, maybe getting. Definitely make sure you got formulas and maybe an example on your sheet if you could. All right, and then from here, this is easy street. This is geometry level trig right now. That's our right triangle. We'll use SOHCAHTOA here. Labeling my sides, I've got hypotenuse, opposite, and adjacent. I'm going to need to write something with opposite and hypotenuse. Is that sine, cosine, or tangent? Fine. Good with sine. Angle is 24, opposite over hypotenuse, so h over 60.90. And then we just have to solve that, figure out what h is. However you want to solve that, I'm going to kind of skip steps. And I'm getting about 24.8. Probably should put some units in here. 24.8, what? 24.8 bananas. 4.8 miles. What are we talking about here? Feet. 24.8 feet. So my picture's not super well to scale, but that does seem reasonable to me. All right, any questions? We're moving on, unless there's questions. Next one's about sector area. This is going way back to geometry. The reason I'm putting this in here is because, well, you're responsible for all of this stuff involving angles and circles and everything. So this is, I'll be honest with you though, this is not something that we cover at all this semester.
I was like, oh.
However, this is something you should be able to do for sure. And CWU people, they may throw you something like this on your exam. So it does relate to what we've done, although we have not done this specifically. If you remember from geometry, a sector of a circle, so I'm going to draw myself a circle. A circle has a central point and a whole bunch of other points that are all equidistant from that central point. And this one is telling us that the radius of this circle is 3 inches. And it has a central angle of 4 pi over 3. No, it doesn't have a central angle of 4 pi over 3. That is a really confusing sentence. What is the 4 pi over 3? Read that sentence to yourself a couple times. If you're not being careful, you might read it and say that the central angle theta is 4 pi over 3, but I don't think that's true, is it? You got to use your language skills here. What is 4 pi over 3 inches squared? That square part on the inches should be a big hint.
140 degrees.
It's not the angle, it's what? Someone just said it. It's the area. If you read that sentence carefully, it says the area, blah, 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 is 4 pi over 3 inches squared. Right? It's weird that they separated, that sentence separated what it was and the value that it was are on opposite ends of the sentence. But if you read that carefully, the area, this is the area. That's tricky. I have no idea what the central angle is. So I'm just going to guess that it's like that big. I don't know. I'm going to guess that it's that big. The central angle here, and I'm going to call it theta. Here's the part that all of you should be able to do. The area of the full circle is what? What is the area of the full circle? Not 4 pi over 3. That's the area of the sector. The sector is this little piece right here. That's the area of just this little piece. What's the area of the full circle? The area. What's the formula for the area of a circle? This is something that you should all know. R squared. And R is 3. So the area of the full circle is 9 pi. What I think I would do for this problem is I would probably set up a proportion. I'm going to set my proportion up so that I'm doing the part on the top of my fractions and the whole on the bottom of my fractions. For example, I know the area of the whole circle is 9 pi. This is an area, right? What would the area for the part of the circle that we're interested in be? 4 pi over 3. What are they asking us to find here? Theta, which is an angle, right? Now, is theta that angle the angle for part of the circle or the whole thing? That's part of it. So I'm going to put theta here on the top because that's part of it. And what is the angle for the whole thing? 360 if I want my answer in degrees, right? Do I want my answer in degrees? Nope. It says give your answer in radians. So instead of 360, I'll use 2 pi. Cool. Now all we gotta do is cross multiply and stuff. Any questions up to that point? So you did lots and lots of proportions in geometry and some in algebra too. All right, cross multiplying. 9 pi times theta is 9 pi theta. 4 pi over 3 times 2 pi. I'm just going to write it out. 4 pi over 3 times 2 pi. That's going to get kind of messy. I'm going to go ahead and divide by pi on both sides. That'll help out with some of the mess. How can I get rid of that 9? I could divide by 9 on both sides. You want to divide by 9 on both sides? That would cancel. So I think we're all set now. Theta equals 4 pi times 2 would be 8 pi. 3 times 9 is 27. 8 pi over 27 radians. Fine. How do you get what? That was given to us in the problem. That was the area of the sector. So that's the area of the part, which is why I put it on the top. So in the end, these were both areas. This is the area of the portion, this portion here, and this is the area of the whole thing. And then these were both angles. This was the area of the part that we didn't know, and 2 pi would be the angle of the part is what we didn't know. The angle of the whole circle we know for any circle is 2 pi. And then it's just some algebra from there to figure out what it is. And that does not simplify, so we just gotta leave it like that. We good on 27? Questions on, I'm sorry, not 27, number 2? Number 2, questions on 2. All right, moving right along. All right, this is at a level that you definitely will be tested on, whether you're CW or regular. You should know how to solve this. We did lots of these. Those of you who are taking or retaking the chapter 5 test, you got one of these you're going to be doing. Yes. Question? Great question. Yeah. So your pink sheet that's got the identities on one side and the unit circle on the back, you'll be provided with a copy of that for the test. CWU people as well. It won't be pink probably, but you will be given a copy of that. Yeah. Mm-hmm. It will be It's the same thing, chapter 5. It's a good question. I don't know what you're going to put on your half sheet. There's a lot of it's there. Good question. Let me talk to Skaggs on that. Yeah. Let me say maybe on that one. Okay, I'll let you know. In my mind, a half sheet isn't big enough to put all of those identities in the unit circling and everything else you're going to need. But if I'm giving you that exact same thing, then maybe you don't need it. I don't know. Let me get back to you. Okay, I'll tell you next class. Start thinking about what you would put on your half sheet aside from that stuff. You can always copy that stuff over. All right, you're definitely going to want your unit circle whether I give that to you or not, and I'll let you know. All right, so I need you to just recognize when you look at this, when you see cosine squared and a cosine in here, and something that doesn't have a cosine in it, you should be thinking that's a quadratic. I need to make it look like a quadratic and solve it by factor. That means you got to get a 0 on one side. Okay. How do you know that? Because you did 10 problems just like this in your homework and your review. That's how you know it. Okay. So when you see something like that, you just got to know. This, you'll see it in Calc 2. So you just need to know when you see something that looks like a quadratic, make it look like a quadratic. Whether you do your substitution now or after you get the 0 on one side doesn't really matter. I'm going to go ahead and do the substitution first, and then I'll get a 0 on one side after that. So I like using W. Let W equal cosine X. Then you need to rewrite this equation, take out all your cosine X's and replace them with W's. So instead of 2 cosine squared X, that's 2W squared. Instead of cosine X, that's W. So you get 2W squared equals 1 minus W. We just turn that into an algebra 1 problem. My algebra 1 students are solving equations like this right now. My algebra 1 students know to solve an equation like this, you need to get a 0 on one side of the equation. They would show a couple more steps to get that 0 on one side, but they would know that you have to have a 0 on one side to solve a quadratic like this. My algebra 1 students have not yet learned about the quadratic formula. That would be an option, but I wouldn't recommend it. That's way more complicated than you should need. You should be able to factor this thing relatively quickly. I know the only way to get 2W squared is to multiply 2W times W, and the only way to get 1 is to multiply 1 times 1. Now I'm trying to get a -1, so that means one of these ones have to be positive and one has to be negative. And I'll just kind of have to think through which one's going to help me get the right thing after I FOIL it out. I want a positive 1W. This is going to be 1W. This is going to be 2W. So I think I want this to be negative. 2W minus 1W will give me the positive 1W, which means we want a minus there and a plus there. If all that's not comfortable for you, you need to practice your factoring, okay? Or else you use the quadratic formula, but I'll tell you next year in Calc, if you're taking Calc, you better be able to factor polynomials like that pretty quickly. All right, so from there, then we should be able to split it up and make 2 smaller equations. 2W minus 1 equals 0, and W plus 1 equals 0. We should be able to solve those 2 equations and figure out what W is. And I'm not going to show my steps here like I would if I were in algebra 1. I'm just going to jump straight to the answers. 1/2 and -1. That's all fine and good, but we're not trying to find W, we're trying to find X. So we need now that we've got solutions for W, we go back and resubstitute what was W. W was cosine X. So cosine X equals 1/2 and cosine X equals -1. And now we can look to our unit circle. We're looking for angles where the cosine is 1/2, positive 1/2, or negative 1. I believe we're going to come up with 3 angles on the unit circle. I'm going to see if I can remember these from memory. Cosine is 1/2 60, that'd be pi over 3. And cosine is 1/2 negative 60 or 300, which is hang on, don't tell me. Don't tell me. 10 pi, no. 300 is, oh, how am I having such a hard time? That's 60 times. That's 5 pi over 3. 5 pi over 3. Am I doing all right so far? And cosine is negative 1. It's 180 degrees, which is pi. And so those would be our 3 answers. All right. Question on that one. We also saw problems where instead of it being a quadratic, it was something like, so this would be a separate problem, like sine x cosine x plus cosine x equals 0. And we had to factor out a cosine x. And then create 2 small equations and solve those. Cosine x equals 0, sine x plus 1 equals 0. So you should be comfortable factoring. That's it. It's the stuff. You should be able to be comfortable solving by factoring when it involves trigonometric functions. Yes. So I got my unit circle memorized. If you don't, then for example, cosine x equals 1/2. So you're looking at this, and you know that cosine is the x coordinate of every point on the unit circle. So I'm looking around here and trying to find x coordinates that are 1/2. One of them's here at pi over 3. That was one of my solutions. The other one here is at 5 pi over 3. That was my other solution. And then we also had cosine x equals negative 1. The only place that has an x coordinate of negative 1 is right here at pi, which is my third solution. So you just have to look at your unit circle to find those values. Or have it memorized. If you're going to be taking more than a year of calc, then you will eventually have that memorized. Be able to do it from memory. Faster than I just did it. I'm rusty. Okay, some of you are already getting started doing that, which is awesome for those bonus memorization quizzes. The reason I'm having you do those now, you don't have to have them memorized for this class. Yeah, you're going to forget them over the summer, but every time you have to memorize something, it gets easier. All right, last one we'll do. We did not do a whole lot of these. Some of you did. Do you guys remember that optional sine cosine challenge thing? I know a couple of you in here did it, and there was a problem about power consumption over time, and we had to figure out over the course of the year. So this is kind of like that. For the CWU exam, you'll definitely run into one like this where it's a word problem. For the regular exam, it's more likely you're going to have a picture and you'll have to write the equation from an actual graph. So what makes this one difficult is you have to sketch the graph for it. So we have to read through here really carefully and figure out what this thing is going to look like. So reading through air conditioning unit in a home is set to go on when the temperature reaches 76 and go off when the temperature drops to 70. And the warming and cooling in cycle that repeats every 20 minutes. So far you get the idea. Temperature's going up and down between 70 and 76. Is that a phone out? Could you put it away? Focus on what we're doing here. Thank you. So we're going back and forth between 70 and 76. So can you envision what this thing's going to look like when we graph it? It's going to be like a sine or a cosine graph. It's kind of going up and down between 70 and 76. In fact, it might be a good idea to go ahead and sketch it. So there's 70, 70 and 76. And I know that this thing's just going to kind of keep going back and forth between 70 and 76. And we know it's going to repeat every 20 minutes. Every 20 minutes it repeats. So from there to there should be 20 minutes. And in terms of equations for sine and cosine, what is that? Is that t or is that omega? That's t. T tells us how wide one period is. So when they're saying something repeats every 20 minutes, they're telling us how wide the period is. Okay, this is starting to come together. So assuming the cooling and heating cycle can be modeled with a sinusoidal function, that's great. We drew a sinusoidal function already. If the temperature of the house at noon is 73 degrees and rising, okay, so let's get 73 on here. The nice thing is about this problem is 73 is exactly halfway between 70 and 76, right? So, so at noon, the temperature is 73 degrees and rising. Which of these 2 points could be noon? The one on the left or the one on the right? The one on the left would have to be noon. You see why? Because it's rising there. The one on the right is at 73 and falling, but here it's 73 and it's going up. So we could say that this point right here is noon. It says write a trigonometric equation to express the temperature as a function of the number of minutes it's noon, and then determine the next time that the air conditioner will shut off. All right, let's take these one piece at a time. Let's see if we can write ourselves an equation. Do you remember what a trig equation looks like? By the way, this is going to be our y-axis now. Does that look like a sine or a cosine to you? Looks like a sine to me because it's starting at kind of the center line. If we think of this as the y-axis, it's starting in the middle and going up from the y-axis. Is that a positive sign or a negative sign? It's a positive sign. Good. You guys are remembering this. So we might need a number out in front of our sign. And inside, we're going to have an x. And are we going to need a left or a right shift? I don't think we're going to need a left or a right shift. If we're taking this as a sine and this is the y-axis, we don't need to shift it left or right at all. All we need in here is an omega. Huh. Not anymore. He used to be scheduled in this class, but he had a schedule change. And we might need a vertical shift on the outside. In fact, I'm absolutely certain we're going to need a vertical shift on the outside. Because for a sine, normally this would be at the origin. How far do we have to vertical shift it up to get it to here? 73. Normally this would be at 0, right? But we had to shift it up to get it to 73. So we know that's a 73. Remember, this number on the outside tells us how far up and how far down we go from that center line. How far up and down are we going? We're swinging up 3 and we're swinging down 3. So this should be a 3 out in front. And then all we're looking for now is omega, and we've got this thing. Do you remember the relationship with t and omega? It's the same equation, whether you're going from omega to t or t to omega. That's the convenient thing about it. Omega is 2 pi over t, t is 2 pi over omega. we need omega, we've got t, so omega would be 2 pi over 20, and we can simplify that a little bit. That's pi over 10, and that's what's going to go here. And there's our equation. Just pi over 10x. Now, sometimes when we were doing these before, sometimes inside of here, we had another set of parentheses and then a left or right shift. But I don't think we need to shift this thing left or right again. If I wanted to, I could shift it to the right to here, but then it would become a negative sign. That would make my equation more complicated. It would still be correct, but do we really want to do that? I'd say no. Let's just leave it where it is. We don't need to shift it left to right. The 3 came from the fact that from the center to the top, from the center to the bottom is 3. So my final equation for this would be y equals 3 sine pi over 10 x. That needs to be in parentheses, and then outside of the parentheses plus 73. So again, on the regular exam, I wouldn't expect most of the problems you're going to see like this will have a picture accompanying them. On the CWU, you'll have to sketch your own picture. Okay, so you need to be able to take the information that's given and sketch a picture. All right, the final thing says, determine the next time that the air conditioning will shut off. Does the air conditioning shut off at the low temperature or at the high temperature? When does it turn on and when does it turn off? You got to think about how an air conditioning works here. The air conditioning turns off when it gets too hot, turns on when it's too hot, and it turns off when it gets to 70. Yeah. So when's the first time that it's going to turn off? On the graph, can you picture where that is? Are you looking at this point right here? Awesome. We actually don't need to use any kind of trig or algebra or anything to solve for this. We could just figure out how many minutes that would be. If we knew that it's 20 minutes from here to here, right? This is one full period, correct? We could chop it up into our little window panes. How big would each of those little sections be? 5 minutes, right? 5 minutes to get up to 76, 5 minutes to get back to 73, 5 minutes to get down to 70, 5 minutes to get up back to 73. That gives us a total of 20 minutes. It fits. So what time is it going to turn off for the first time? 12:15. So the answer to the second part would say 12:15. All right, we got a little bit of everything in there. Some triangles, some areas, some trig equations. Your homework assignment is going to focus mainly on chapter 4 stuff. And I'll go ahead and write that up on the board here so that you guys have that. Get ready, started on it. Give me just a second. On Canvas as well.